So, till now what we studied is the OSI model, the different layers of the OSI model, the services of the different layers, the routing protocols and the MAC layer protocols as well as your data link layer protocols. Now, the counterpart of this OSI model is another model, that is the TCPIP model, and it stands for the Transport Control Protocol versus the Internet Protocol, TCPIP. If you compare the TCPIP with the OSI model, then we can compare these two, OSI and versus the TCPIP. They are different in terms of the number of the layers. The layers, their numbers, their names. Like for the OSI model, if the number of layers are 7, for this TCP/IP the number of layers are 4. And while coming to the name of the layers, the application layer remains for both these two, and the presentation layer and the session layer which is present in the OSI model is not there in the TCP/IP. So, you have the protocol stack like this. Your file layer and the DLL are considered to be present in by some authors, and they also may be considered as a single layer and may not be considered as a distinct layers for the OSI model. Above this you have the network layer, or what we say the IP layer. For TCP/IP model we say this is the IP layer, Internet Protocol layer, and above this we have the transport layer, same as your OSI model, and above the transport layer is your application layer. Now, these are the 4 layers of your TCP/IP protocol suite, and this IP or the network layer in the OSI, the data units are called the datagrams. If you remember the OSI model, they are called the packets in OSI model, but the same is now called as the datagram by this IP layer or the Internet Protocol layer. The reason is that both of these two layers in different, all these two OSI and the TCP/IP, they differ with the kind of the services they provide. So, one is the number of layers and the services they provide. If you compare the IP layer or the network layer, in OSI model the network layer supports both the connection oriented and the connection less service. So, we have a packet switch, you have a circuit switch which supports the connection oriented, and you have a packet switch which supports the connection less. While coming to the IP layer, IP model or this TCP/IP protocol suite, this only supports your connection less service or the packet switch concept. Because it is connection less, so we assume that the data units are the datagrams that follow the packet switching method, or they can travel any path while traveling from the source to the destination. So, when I say about the packet, it is mean that it is from the OSI model. When I say about the datagrams, it comes to the IP or the TCP/IP model. The second difference is, this is one difference with respect to the network layer. Coming to the next layer, the upper layer, or which is the transport layer. In case of the OSI model, the transport layers provides only the connection oriented service. The transport layer supports only connection oriented service. Coming to the TCP/IP, now it supports both the connection oriented and the connection less service. So, we have two protocols in this model. One is the TCP, which is connection oriented, another is UDP, which is connection less. So, now if you see the OSI model and the TCP/IP model, the TCP/IP model is more of the protocol oriented, depending on the kind of the protocol, designing of the protocol or objective of the protocol, the layers are designed accordingly. While coming to the OSI model, they are more of the service oriented. So, while OSI is a service oriented protocol, the TCPIP becomes a protocol oriented model. These are the basic differences between the OSI and the TCPIP. So, for this TCPIP what we will study today or hereafter, every protocol has its own designing and we have to understand what is the designing concept of the layer and the protocol associated with the layer. And this IP, as I told you, the protocol of the network layer, it is supported by few other protocols in the same layer. So, some of them are, one is the ARP, the Address Resolution Protocol. The Address Resolution Protocol. What this protocol does, if you give the IP address of a host, it tries to find what is the physical address or the MAC address of the host. This is a control packet or control protocol which tries to get the MAC layer of a system or a host whose IP address is known to you. The reverse is counterpart of this is the RARP or what we say reverse ARP protocol. The reverse ARP protocol. And what it does, if the physical address is known or the MAC address is known to you, then you can obtain the IP address or the logical address of a host using this protocol. Next to the ARP and RARP is another protocol called the ICMP, Internet Control Message Protocol. If you have worked in the internet, have you ever realized ICMP error is there? Have you ever got any message ICMP error? What is that? Host unreachable, ICMP error, something like that. So, this is a kind of protocol that responds to the sender saying the status, or it is a kind of giving an error report to the sender. It sends a message to the sender saying that there is a kind of error which has to be fixed. That is what is your ICMP, Internet Control Message Protocol. And another is the IGMP. We will study the details of all these protocols later. Another is the IGMP, Internet Group Message Protocol. If a message has to be sent to a group of people or group of hosts, then this IGMP takes care of that. When a single message to be received by multiple or a group of people or group of hosts, then IGMP protocol is used for that. So, your IP associated with this ARP, RARP, ICMP and IGMP all these are called your IP layer protocols or network layer protocols for TCP/IP model. Now, when we say about this IP, Internet Protocol, where you use this word IP usually? In case of addressing a host. Most often you use this is the IP address of a host. What does it mean? What is the IP address of a host? Why you say this is IP address of a host? What actually is meaning of IP address? What is the other name of this IP address? IP address of any host is also called the logical address of your host. What does it mean? This address is logically designed by the designer, keeping in mind the location of the host, the kind of addressing mechanism is used for that host or that network. Some logical designing mechanisms are used to give the address to a particular host. So, we say that is a logical address. So, every host in a network, when we say it has two addresses, one is the MAC, that is the physical address, another is the IP, that is the logical address. This is fixed during your manufacturing. We cannot change that unless otherwise you change the NIC card. But this could be changed if you change even the location of a host from one building to another or one room to another, the IP address will be changed. That means this IP address in a network says the location of the host means I am saying about the system where it is physically present. So, every IP address of a host, what we are using currently is the IPv4 or IP address version 4. What this says, this IP addressing is nothing but a 32-bit address. Let's talk about the IP address now. It's a 32-bit address, or what we say 4-byte address. And with this 4-byte, we divide the address into two parts. One is the net ID, another is the host ID. What does it mean? What is net ID and what is host ID? Any system that is connected to the internet or to the globe is present in one network first. So, what is the network? Where is the network address where the system is present? Which network it belongs to? That signifies your net ID. And within the network again, where the physically the system is available or present defines host ID. It's like identifying any student, the hall where he is present, and within the hall again which room number he is available. So, it has got two addresses to identify a host, because the searching time of host will be minimized if it is identified hierarchically. So, with this we have a series of addressing schemes for identifying a host in the network. Let us say I will divide this 4-byte as 32-bit as 4-byte address. Byte 1, I have 4-byte addresses. Let us say I will take 1 byte or the first byte as the net ID, and the rest 3 bytes I will take as the host ID. That means what I say, I have 8 bits to identify a network. So, with this 8 bit, how many networks can be identified? 2 to the power 8. So, that becomes the net ID of a host, and within that net ID I use 24 bits as the host ID. That means it could be one host among the 2 to the power 24 number of hosts. So, you have such a big network now. Totally you have got 2 to the power 8 number of networks, and within each network you have got 2 to the power 24 number of hosts. So, when a particular host has to be identified, you have to search what is the net ID, that means in which network is available, and within the network where is the host. The network having 2 to the power 24 number of systems or hosts. So, to classify this kind of addressing schemes, the first class is the class A addressing. Class A addressing, where 1 byte is used as the net ID and rest 3 bytes are used as the host ID. And out of this 1 byte for the net ID, the first bit or first digit is the considered to be 0. So, for a network of class A kind, the net ID is out of 2 to the power 7. It could be any number between 0 to 2 to the power 7. So, a network that starts with 0 to 127 is considered to be the class A kind of network. Any IP address that starts with a number between 0 to 127, you can say that this address belongs to class A kind of, and rest 3 bytes are your host ID, so we do not bother for that. Coming to the next kind of class address, you have the class B kind of network, where 2 bytes are used as the net ID and 2 bytes are used as the host ID. And the addressing starts with a numeral 1 followed by a 0. So, your net ID for class A says any network between 2 to the power 14 number of networks, because 2 bytes we have reserved for class B, identifying this as a class B. So, an IP address that starts with 128 to 191 can be considered as the class B address. Make sense? Following this, you have another kind of network or class of address, which is a class C address, that is 3 bytes used as the net ID and 1 byte is used as the host ID. So, the number of networks in class C are more, and each network is of smaller size in comparison to the class A and class B. The reason is from the maintenance point of view. Have more number of networks of smaller size instead of having less number of networks of very big size. So, in this the net ID starts with a series of bits, that is 2 ones followed by a 0, indicating that this is a class C kind of address. And numerically, if you say this is from 192 to 223. So, our institute has got which class of addressing? Class C, because we always see that it starts with 192. So, this is a class C addressing, and rest are of course not being used much. Another is a class D, which we say as the multicast addressing. This is basically for multicast, and here 3 ones followed by a 0, that is for your multicast addressing. And this usually starts with 224 to 239. This is class D. So, you have the addressing numbers of the IP address for any host or any packet. You have 4 bytes, and the first byte starts with a number which signifies for the kind of class it belongs to, class A, B or C. You understand that this packet belongs to this class of, or this addressing is for this class network, and from there you distinguish the net ID, distinguish the host ID, and accordingly the network designer designs the network. Now, before designing a complete network of IP address, we must take care that there are certain IP addresses which are reserved for specific purposes. They cannot be used as an host address, because randomly when we allot an address to our host, we give any number. If you understand we are in class C, I can give any number 192.x.y.z. But before assigning any number, the designer must keep in mind there are some special kind of addresses which cannot be allotted to one host. They have the significance for different purposes. One of them is an IP address that defines the network address. When I say an IP address that defines the network address, meaning it is having only net ID and all the host ID will be equal to zeros. So, if I say I am using a class A network, in the class A network, any network will have the address, let us say 123 is a class A address followed by all zeros. That means all the host ID will be 0, and this address can be given only to a network, not to any host in the network. So, the host connected to this network, they will have a number 123.x.y.z. So, when all host IDs are 0, we say that this is a network address. Similarly, for a class B address, if I say, it will be something, let us say 130.46.0.0. Net ID could be anything, but host ID has to be all zeros for a network address, and the host connected to this, they will have 130.46.x.y or any number they can have. Similarly, for a class C, if you say, in our case, it could be, let us say 192.x.y.0. That means this is a network address, and the host connected to this can be any number to this. So, this is a special address when you say all the hosts are having a number 0, the series of zeros for all host ID, meaning this is a network address and it cannot be allotted to a host. If you allot this number to a host, you just check it and see what kind of message you are getting. That is what is a network address. Then there is another kind of a special address called a direct broadcast address. Direct broadcast address. In this, what happens? All the host IDs are ones. That means it indicates that the destination is to add all the host. The packet has to be delivered to all the hosts in the network. So, these kind of addresses are specially used by the routers, because router has to deliver the packet. So, when a packet comes to a router, let us say we have a router and this router is connected to a network, Now let us say the packet that comes to the router is having the address 221 dot let something 45 something 71.255. 221 means which class of addressing is this? C. So obviously host ID is this one. And when we say host ID 255 means it indicates that host ID is all ones. So this is your net ID. Now when this is your net ID, that means the address says that the packet has to be delivered to all the hosts available in this network. So where is the network? Here is the network whose network address is same 221.45.71.0. So the router that is connected to this network will now say that packet I am receiving with this IP address has to be delivered to this network whose address is such, and this packet will be received by all the hosts in the network. So it comes to this 221.45.71.255. So it is now received by all the processes in this. So this is a special kind of address which is used as an destination address by the router. So this is what is a direct broadcast address, and this address cannot be given to any host. This is for a class C. Similarly, for a class B it will be something x.y.255.255. All host IDs are 1. So any network having class B address of x.y.0.0 will receive the packet and will distribute or deliver the packet to each host in the network. Then another kind of special address is this host in this computer, this network. This is termed as this host in this network, meaning what? Let us say I have a network, the host is connected here, and the host comes up for the first time. It starts for the first time. So what it does first? A host which is connected to a network and it comes up for the first time, it first tries to understand where I am, what is the location. So to understand this, what is my IP address and what is my MAC address and what is the locality of connection to me, what it does, it sends a signal or sends a control message to the bootstrap server. And the bootstrap server says to it, the host, that you are a host having this IP address, and from this IP address it understands to which network I am connected and what is my host ID. So this is a special kind of address having all the net IDs 0 and all the host IDs 0, and this can be used only as a source address. If I give this, that means a system when it comes up, your address will be this host on this computer. It does not have to go anywhere else, it does not have to identify any other host, it has to only identify itself in this network. And who does it is by sending this message to the bootstrap server who says that your IP address is such and such, and then it gets activated and this things moves. Then another kind of special address is a specific host on this computer or on this network, let us say. Sometimes what happens, you have multiple networks, maybe of different classes, maybe of the same class. What we do, in between these networks, either there may be a router who forwards it, or it is directly connected so that the packet goes from this to this. There is a gateway and who does it. Anyway, it is possible. Let us say there is a sender here, there is a sender host here, and the destination is here. And this address has got, let us say, we will talk about the class C addressing x.y.z.0. So let us say this is a.b.c.0, and this address is, let us say, x.y.z.9, and let us say this address is a.b.c.15. So when this fellow generates a packet, the destination address of the packet is this one, a.b.c.15. This is the destination address. And when this sender sends the packet to the router or to the gateway or to anyone, any intermediate hub, the router or the gateway understands that this packet is for somebody else, not for the host inside my network, because the network address is a.b.c, which is not mine. So, it tries to find out a network whose address is a.b.c.0, and then as we saw in the previous case, the packet is forwarded to this gateway or this router, does the same thing and hands over the packet to this network where the destination is identified. But let us say there is a sender here in the network x.y.z.0 and the receiver is also here. Let us say the destination is here x.y.z. Let us say 9. Oh, this is let us say 10. So, in that case, when this packet is generated, it generates a packet with the address of x.y.z.10. It understands that the host is in my network. It is a specific host in this network. The packet does not have to go outside the network. So, in that case, what the sender can do, instead of giving the destination address as x.y.z.10, it can give 0.0.0.10, meaning the net ID is all zeros, indicating to the router that this packet does not have to go outside the network. It has a destination somewhere inside this network. So, when the packet goes to the router does not forward it anywhere else. It keeps the packet within this, or this is a kind of filtering of the packet from moving ahead. Otherwise, what the router will do? It will forward and again it will go on searching the packet somewhere in the network, the whole of the thing takes place. So, to avoid that, the sender can say that my destination is in this host, in the specific host on this network. So, he gives a net ID equal to all zeros and followed by the host ID address. So, when this packet is forwarded to the router does not let it go out of the network. It tries to find the host destination inside this and delivers the packet to this. So, either you can have a all host ID is 0, saying that this is a network address. You can have a all host IDs 1, saying that this is a broadcast address. You can have the net ID zeros, saying that this packet belongs to this network only, it does not have to go out. Or you can have all zeros when the system itself comes up in the network. Along with this, there is a special kind of network and the special kind of IP address you have used quite often. Have you ever used any network or any address like ping 127 dot something something? Why you do that? What is that called? It is called a loopback address. Why you use this loopback address? When you use this one? It is a address to check that your host is connected to the network, to any network, to some network, or the network protocols or the network software is active in your host. So, you say ping 127.0.0.0 something and you get back a message immediately. This is what is a loopback address. It is a special kind of address to test the network softwares on your machine, on the host. What it does? It checks for all the network protocol stacks, saying that they all work fine, and your host is now eligible to be connected into a network, and it can receive the packet or it can send the packets further. So, these are the some of the special addresses which has to be reserved for special purposes without allotting them to any specific host. You cannot give allot a number, just check it with net ID zeros or host ID zeros or all zeros or a 127 number. You definitely get an ICMP message back to you. This is what is called your IP addressing. How you address a particular host, how you allot a host, the IP address to a host. That is why this is called a logical address. This is in the control of the designer. He says what kind of address I can give. in which domain it has got. You have different kind of addressing schemes, right? You have a subnet, you have a subnet mask, right? You have a subnet mask. What is a subnet mask? We will see them later, the next class. So, different addressing, IP address followed with different addresses specifies the network, specifies the host in a particular network in the internet. So, understanding the IP address is a vital part to understand the network, computer network, or delivering of the packet to any host in the network, right.